Hello, welcome to the next session of Lean Six Sigma Black Belt. We have already seen define and measure. Now let's get into analyze phase. Hope you are aware of the tools and techniques in analyze phase. In green belt level, we have discussed all these tools and techniques. Let us see an overview of that. The first tool, Pareto chart. So you'd be remembering that we have plotted the causes in descending order on x-axis, and we have the frequency on the y-axis, and we have the cumulative percentage on the alternate axis. So first, what did we do? We were drawing the bars. The first thing is we were drawing the bars based on the frequency, right? So after drawing the bars, we have to mark the dots for the cumulative percentage. For each cumulative percentage, we have marked the dots here, and we are connecting all the dots together to form a curve. Then we have to draw a horizontal line at 80%, and wherever it touches the curve, you draw a vertical line. So all the causes which falls within the vertical line is called the vital few causes, or the 20% of the causes. Then you have the remaining causes. They are trivial many causes. They are the 80% of the causes. Okay. So the 20% of the causes leads to 80% of the problem. So why are we doing Pareto? To identify that most important cause. So in this situation, we have 1, 5, 4, 10, 9, and 16. These are the most important causes. That is 20% of the causes leading to 80% of your problems. So what we're going to do after all these theoretical session, I'm going to show you all this Pareto, cause and effect diagram, correlation, all these concepts I'm going to show you for the production concept. We have already taken the case study, productivity value. So we are going to see how we are going to get Pareto chart and remaining other analytical tools for that particular project. And fishbone diagram. So what is the other name for this? The cause and effect diagram. So here the central bone refers to the effect, the peripheral bones refers to the causes, right? So what is the relationship between the effect and the causes? So this is called cause and effect diagram because for one particular effect, what are the different causes? We are identifying it and we are relating it. And we have 6 M's for that: man, machine, measurement, mother nature, material, and methods. Then we have correlations, the relationship between X and Y. So correlation, that is, if an X and Y are there and they are related to each other, then it is said to be correlation. So we have already discussed few examples, and the X variable is also called independent variable, Y variable is also called dependent variable. X variable, the other name is predictor variable, and Y variable, the other name is response variable, right? So when X increases, Y decreases. That is called negative correlation. Okay. When X increases and Y decreases, that is called negative correlation. When X increases and Y also increases, that is called positive correlation. When X increases, Y also increases, that is positive correlation. Okay. So we're going to see whether it is positively correlated or negative correlated. How to do that? So for that, you need to get something called R value. So if the R value is 0, there is no correlation. If it is 0 to -1, it is negative correlation. 0 to +1, it is positive correlation. How to get this R value? You can go in mini tab. We go to the option stat, basic statistics, select correlation. When you select correlation, you will get R values, and based on the R value, you have to select whether it is positive correlation, negative correlation, or there is no correlation. Then we come to the next scatter diagram. A scatter diagram depicts the graphical relationship between two variables. So what did we do in correlation? We identified the relationship between two variables x and y using the value of r. In scatter diagram, we are going to draw a scatter plot and we are going to decide it. So we have already done these examples, college entrance marks and college graduate marks. So we identify which is y and which is x. So here, the graduate marks depends on entrance marks. So graduate marks is y and entrance marks is x. So what are we doing? We are drawing an x-axis and y-axis, plotting entrance marks and graduate marks in x and y, and mark the intersection points of the graph. So that is what we have done here. Entrance marks and x-axis, graduate marks and y-axis, intersection points you are marking as a graph. Now what you can do is, I'm giving you two more examples for scatter plot. See, we have done only for positive correlation. Now you have to do for two more exercises. So take productivity and downtime, which is x, which is y. So downtime is x, productivity is y. Productivity depends on downtime, right? So you have to take productivity, you have to take downtime on x-axis and productivity on y-axis and start plotting a graph like this. Okay. One more example is sleeping hours and productivity. Here, productivity percentages y-axis, sleeping hours is x-axis. So you have to plot sleeping hours in the x-axis and productivity percentage in y-axis and get the scatter plot. So finally, you will be getting any one of these four patterns. If you get if a pattern is similar to the first picture, then it is negative linear correlation. The second one is positive linear correlation. The third one is no correlation. And the last one is non-linear correlation. Non-linear correlation is something where it initially increases, then decreases, or initially decreases, then increases. Okay. So what do you mean by linear? Linear means straight line. Here, the last option, you're not getting it in straight line. So that is non-linear correlation. So you can identify the patterns of these two examples and you can share it with us. Now, we have already discussed about regression, predictive analytics, right? The prediction of dependent variable from the knowledge of one or more other independent variables. So prediction of dependent variable, that is what we're going to do from that. There is simple regression, multiple regression. Simple regression is there, then we have multiple regression. If there is only one x, that is called simple regression. If there are many x's, that is called multiple regression. So we discussed about the formula for that. Y is equal to a plus or minus b of x, that is for simple regression. And then for multiple regression, y is equal to a plus or minus b1 x1 plus or minus b2 x2 plus or minus infinity, right? Hope you remember the example we have taken, broken chips percentage. The broken chips percentage is the response. And there are two more variables we collected, cooking temperature and percentage of potato. When you take all these data and you do a regression analysis, you're getting an equation, and that equation is this: broken chips is equal to 4.231 minus 0.044 into percentage of potato plus 0.023 into cooking temperature. Now what we have done in that, we have applied three combinations in this formula and we are getting the results. Whichever combination has a maximum has a minimum percentage of broken chips, you need to select that, right? So we are getting a answer here as 6.355 and 6.1. So the second combination has very, very less percentage of broken chips. So we go for that option. So we're going to do regression analysis also for our production project that we'll see in the Minitab session that we're going to have in the next. Next is hypothesis testing. So we have already discussed about hypothesis testing. It is nothing but assumption. So whenever you start a hypothesis testing, the first thing is you have to draft a hypothesis statements. So what is the hypothesis statement? Whether a null hypothesis and alternate hypothesis. Null hypothesis always says no significant difference. Alternate hypothesis says there is significant difference, right? Then you collect the data and you are having the alpha values, and then you collect the p values, calculate the p value, right? So in hypothesis testing, you calculate alpha value and you calculate p value. Alpha value is 0.05, that is nothing but the 5% of the error that you're going to get in your experiment, in your test. And then you calculate the p values. So p values we'll be getting in the respective test, t test, z test, one variance test, or two variance test. You'll be getting it from the Minitab. 0.05 alpha value we have to, this is an that is standard value. Alpha value will not change for any other test. Now what we are supposed to do, we have to compare both the values, and the test results from the Minitab will give you all the necessary contents. Only one point that you need to remember is, if P is low, alternate hypothesis is rejected. If P is high, null is accepted. Okay. If P is low, alternate is accepted. If P is high, null is accepted. You have to remember this very point, so that you can do all hypothesis testing without any hindrances. So in the next session, I'm going to show you all the hypothesis testings. So I can just display that. What are the different hypothesis testing we are going to learn from Minitab. See, at green belt level, we have just got an introduction about hypothesis testing. Only at black belt level, we are getting into the depth of the each and every hypothesis testing. Okay. So this is a broader classification of the hypothesis test. So in all these tests, we are going to compare only one thing, that is the alpha value and p value. Okay. And after comparing alpha value and p value, we have to see if p is low, alternate is accepted. If p is high, null is accepted. This is the only point that you need to remember. So kindly note down this point, so that the next session you'll be very clear with identifying the which hypothesis is accepted, whether null is accepted or alternate is accepted. Now let me get into the different types of hypothesis testing. Okay. First example, the first thing what you are supposed to see is, what is my y, what is my x? Let me show it one by one. In this example, you can see, so our project is production value, right? This is our project. So that is our y, right? That is our y. And hope you remember, we have taken some examples as in data collection form, we have number of manpower, and we also have manpower hours, right? Okay. So here my y production value, what type of data is that? It is continuous data. Okay. And number of manpower is discrete data. Okay. So if my y is continuous and my x is discrete, I have to use all these tests. I have to use all these tests. I repeat it again. See here in our project, what is the data that we are collecting? Production value, right? That is our Y. That is our end result. That is our response. That is our problem. So first thing, I have to see whether my Y is continuous or discrete. So you tell whether it is continuous or discrete. The total productivity value is continuous. It can take any value in a range. So continuous data. Okay. Now, number of manpower. Number of manpower is discrete data, and that is a X. Whether number of manpower is affecting production value or not. So that is what we are going to check with all these tests. So if Y is continuous and X is discrete, we have all these tests that can be done for that combination. But you have normal and non-normal. If your data is bell-shaped, then you can go for these tests. If your data is bell-shaped, then you do all these tests. That is 1T test, 2T test, 1Z test, 2Z test, paired t-test, one-way ANOVA, two-way ANOVA. All these tests are called mean test. We are going to compare the mean of one sample with the mean of other sample. Then we have one variance test, two variance test, and homogeneity of variance test, also called Bartlett test. All these tests are called variance test because we are going to compare variance of one sample with the variance of other sample. Okay, so if you're going to compare mean, then it is mean test. If you're going to compare variance, that is variance test. All these tests will come under the heading normal. Okay. If your data is not bell-shaped, not normal, then you have Mann-Whitney test, Kruskal-Wallis test, Moore's median test, and Levine's test. So these are the tests that you're going to see if you have, if your data is non-normal, which is non-parametric. It is also called non-parametric test. Okay, so this is all about the combination Y is continuous and X is discrete. X is, you can see the X is discrete. If this is a combination, these are the tests that we are supposed to do. Okay, now if your Y is continuous and X is also continuous, see my X here is manpower hours. Can you see the difference? In the previous combination, we use number of manpower. The X is number of manpower. So if your data that you're collecting is number of manpower, then that is discrete. For that combination, we did all these tests. But if it is Y is continuous, and X is also continuous, like manpower hours, then you do all these tests. We have already discussed about all these tests: correlation, scatter plot, simple regression, and multiple regression. Y is continuous, X is also continuous. In that combination, we use this correlation, scatter plot, simple regression, and multiple regression. Next, we go for discrete. Now coming to the next combination, your Y is discrete. For example, if your project is to increase the number of production, if your project is to increase the number of production, then what data is that? That is discrete, right? That is discrete. So what is your Y now? Your Y is discrete. And if your X is also discrete, okay, your Y is discrete. Let me show you this. So here your Y is discrete. You want to increase the number of production, and X is discrete. For that combination, you have to use these tests. That is chi-square test, one proportion test, and two proportion test. Okay. So your Y is discrete, X is also discrete. That example, you're going to use all these tests. Now coming to the next combination. If your Y is discrete, okay, if your Y is discrete and X is discrete or continuous, then you go for logistic regression, then you go for logistic regression. So these are the different combinations that you are seeing here. So one is, the first combination is y is continuous. So y is continuous. Yeah. So y is continuous and x is discrete. For that, these test y is continuous and x is also continuous. For that, you do these tests. If your y is discrete and x is also discrete, you do chi squared 1 proportion and 2 proportion test. If your y is discrete and your x is continuous or discrete, that is logistic regression, right? So these are the details that we're going to see in Minitab. These are the tools that we're going to see in Minitab. I'm going to take we have already collected the data. I'm going to do each and every analysis using the same data collection form, so that that can be useful for us to understanding each and every concept related to the production project. Now, when it comes to this non-normal test, that is Mann-Whitney test or Kruskal-Wallis test, we have one point that we need to remember. So let me explain that. So before, what you are supposed to remember regarding this non-parametric test is, Mann-Whitney test is a test which is similar to two-sample t-test. Okay. Kruskal-Wallis test is a test that is similar to one-way ANOVA. Moore's median test is the test that is similar to one-way ANOVA. And Levene's test is a test that is similar to homogeneity of variance. So if you're doing normal test and if you're doing non-normal test, I'm going to explain each and every normal test and non-normal test. This is just a tabular column which indicates what is the similarity between these two tests. Okay. So Mann-Whitney test and non-normal test is similar to two-sample t-test. Kruskal-Wallis test is similar to one-way ANOVA. Moore's median test is also similar to one-way ANOVA. And Levene's test is similar to HOV test. Okay. So what we're going to do is I'm going to teach you each and every tool and technique in Minitab in the next session. So let's see in the next session for Minitab related to the analyze phase. Thank you.